Lab Program 11. Design, develop code, and run the program in any suitable language to implement the quicksort algorithm. Determine the basis paths and using them, derive different test cases, execute these test cases, and discuss the test result. So, here, similar to our previous lab program, that is lab program 10, we have derived the test cases based on the basis path. We need to draw the program graph, then the dd graph, then using that we need to write the test cases for the independent paths. So similarly we are doing that for the quicksort algorithm. So as we have already studied quicksort algorithm. So quicksort algorithm, again, it depends upon the concept of divide and conquer. Now here we will use the method like quickly to sort the elements in an array. Now here we can see if an array is given, first will be pointing to the first element in the array and last will be pointing to the last element in the array. And we will have a pivot element that is always the first element. Now in the quick sort, what we have to do is we need to make the pivot element to be placed in a sorted order, sorted position. So it can be in a sorted position when the numbers or the elements which comes before that pivot element, that must be lesser than the pivot element, and the numbers which comes after the pivot element, that must be greater than the pivot element. Then we can say that that pivot element is sorted properly. Now to make the pivot element sorted in the proper order, we are taking two pointers, that is I and j. Now I will be pointing to the first element as usual, and j will be pointing to the last element in the array. Now the I is incremented for each traversal, and after incrementing I, it has to check whether the next element is greater than the pivot element. Similarly, the pointer j has to be decremented for each traversal, and it has to check whether the next element is less than the pivot element. If I is greater than the pivot element and j is less than the pivot element, I and j must be interchanged. So for each traversal, it has to do until I j becomes lesser than j becomes lesser than the pivot, sorry, j becomes lesser than I. So in that case, the jth position will be the correct sorted position for pivot. Now, whenever you place that pivot, the same rule that is applied again and again, the loop has to be uh, repeated until all the arrays in the all the array elements are in the sorted order. So that is what the quick sort. We are just making and pivot element to be sorted in a sorted position, so that the other element which comes right and left of the pivot element, that can be sorted quickly. That's why the name quick sort. Now let's go to the program part. So here as usual, to draw the program graph we need to draw we need to give the line numbers for each statements in the program. After you give the line numbers, here I have just replace the line numbers with the alphabets. So here alphabets, this graph indicates if there is a line numbers, then it is called as program graph. If you name the program graph using alphabets, then it gives you the DD graph, that is decision to decision graph. Now decision for one node, it can be a sequence of several nodes from the program graph. For example, if there is a sequence like 1 2 3 4, that is a chain. So all together you can make it as a one node in dd graph named as a, like that. So we need to draw the dd graph like our previous program, how the program flows from which node to which node. And once the graph is done, we need to calculate the independent paths using the cyclomatic complexity formula. So here we are taking one extra node to make sure that our graph is strongly connected, because if you want to apply the cyclomatic complexity formula, the graph must be strongly connected. So to make sure that we can see in this uh, graph itself, the n node n and j, here node n and j, it is not connected. So make the graph to be strongly connected, we need to draw a node from we need to draw a edge from entry node to exit node. So that's why we are taking that one extra node as one. So by applying these things, total number of edges and nodes and one, you will get total number of seven independent paths in the graph. So with respect to all possible ways of the statement flow or the data flow in the program, we need to write the independent paths. So total there are seven independent paths. So these are the seven independent paths from the program graph which is shown in the previous slide. Now using these path, we need to write the test cases. Now similar to the binary search program, we need to write down the paths. So there are seven paths, and what is the input, what is the expected output. Now in this case, in the input, so in the first case only one element is given, so first and last will be 1 comma 1, so it is already sorted because we have only one element. Now come to the next, it has two elements. Okay, well, it is not in a sorted order, so we need to apply the quicksort formula function. Then once we repeat the same, we will get the sorted array for the two elements. Next, come to the three elements. It can be in any order. So if it is not in the sorted order, we need to apply the quicksort algorithm. So we need to repeat the process until it gets started. Next is, it is already in the ascending order. So we need to repeat the sorted, and finally it will be in the sorted order. Next is descending order elements. So we are trying with all possible cases. So again, for this, apply the sorting law and then get it sorted. Next, pivot is the minimum. Now, minimum value is taken as the pivot element. Now, again, the same thing. We need to put it in a proper position, and so that we can get, after repeating after so many number of traversals, we need to get the sorted array. And finally, again, we have pivot as the maximum. We are taking 5 as the pivot, and we need to apply the sorting algorithm to get the sorted array. So this is what the different test cases. As I told, you are trying with all possible input values for the program, so that you are just cross checking with all elements, like one element, two element, whenever pivot in the middle, pivot in the first element, pivot as the first element, pivot as the last element, like that. So you are making all combinations, and you are just checking for the output. And here you need to give the input with respect to the paths given. So whenever it is abn, that indicates that there is only one element in the array, so it is gets sorted when it travels through these abn path. So that is what, with respect to the path, we need to keep the input. We need to check how the program flows in the graph, which conditions it is satisfying, which conditions it is not satisfying. So all those things must be considered, and then it is proceeded. So that is what about quicksort algorithm. And how to draw the basis path and deriving the test cases. Thank you.